like a simulation of a test circuit for a isolated bridgeless charger. And basically the capacitor over here is simulating a battery on the output. This is my voltmeter hooked across the capacitor. I have a little resistor there just to bleed off any voltage between tests kind of thing. And then basically all it does is it runs electricity through this inductor to this cap, and then the cap you see is split, and this white wire is going to simulate my switch. And then this is a transformer that's isolated from input to output. So as I take this white wire and tap it on negative, which the other side of the power runs straight to the negative of the transformer, that'll create a pulse in the transformer, which then feeds to this cap, which is hooked in series as well. And then there's a diode from the negative up to the output of the cap, and then a diode in series on the output of the cap to this. And then the ground of the transformer just goes straight across to the ground of the capacitor. So let's see if it blows up when I turn it on. So far we have no voltage, it's not blown up. Let's see what happens when I tap that. Yeah, it's working. That's awesome. So all I gotta do is tap this really quickly and it's making voltage. Now you can see it's actually loading my supply down a bit, but I'm probably flowing a decent amount of amps, and the system is totally not efficient at this point. But the system and the theory works. That's what matters at this point. I just proved this really cool charger to be a viable thing. So now my next step is to actually implement the MOSFET in this instead of this switch, or actually to go back into some conversations with Luke and a few other people. You need two MOSFETs with the source of each MOSFET tied together in series. The reason for that is because the MOSFET has an anti-parallel diode built into it, and what you need to do is defeat that, because it's going to continue to flow current. Because the goal of this, when I'm done, is not to hook it up to DC, but to AC, and then do that pulse, and hook up a power factor correction module that'll watch everything as it's working, and it'll try and keep the current in sync with the AC sine wave so that it doesn't phase shift, so it works properly. Now, because we're going to run AC into this, it's not going to be any different, but that's why you need to do either two MOSFETs in series with each other with the sources tied together so they're facing the opposite direction, and pulse them at the same time, or because that way one will work for negative, one will work for positive. Or the other option is a set of IGBTs in parallel to each other instead of series. I'm pretty sure I said series with the MOSFETs. If you do the IGBTs in parallel to each other, what that'll do is you can face them opposite directions, and you can use IGBTs that do not have anti-parallel diodes. And I actually have some of them over here that are rated for some pretty big power. I think these are them here. No, these ones down here. This is a few of them. I have like 30 of these. These things are pretty badass. They'll do like 300 amps when they're cold or whatever. But they're totally overkill for this project. But I have them, and I can make an extremely badass charger with them. They're very low voltage drop. The good thing is they don't have the anti-parallel diode built into them. I have some other IGBTs there that do. They're better for three-phase inverters, because then they'll actually let the freewheeling currents flow when you shut the IGBT off. But in this case, you don't want the freewheeling currents to flow, because that's what makes the circuit work. So just to test again. This might be easier. Go up here. Actually, holding this on there is what's actually loading it down, so you just want quick pulses. And as I said, like, I can do this really fast and try and get the voltage up by all means, but what I'm doing is I'm bleeding it off through this like 5K resistor right there. So I'm trying to pull it back down to 0 to verify that it didn't just work out of fluke for the first try. It's actually sending a current through like it's supposed to. Now in the circuit, there's supposed to be an inductor, a small inductance right here on the output of the cap. I don't have that. I didn't think I would need it just to prove this circuit. So I think everything's happening the way it's supposed to. So on to the next test.